Hi, hello friends, welcome to the channel. In today's video, we'll be seeing non-destructive testing of materials, Unit 4, Part 2. Question number 13. The ultrasonic transducers are the devices used to. Option number A is given as generate ultrasonic waves. Option number B is given as detect ultrasonic waves. Option number C is given as both A and B. And option number D is given as none of this. The ultrasonic transducers are the devices used to. Ultrasonic transducers are used to generate ultrasonic waves and also detect ultrasonic waves. So I am going with option number C, both A and B. Question number 14. The types of ultrasonic transducers or probes on the basis of construction and principle are. There are ultrasonic, we have classified ultrasonic transducers in various types and transducers and probes in various types on basis of construction principle and application. On the basis of construction principle, it is classified into piezoelectric transducer, polyvinylidene fluoride transducers, electromagnetic and acoustic transducers, linear generated ultrasound transducers. Option number A is given as piezoelectric transducers. Option number B is given as polyvinylidene fluoride transducers. Option number C is given as electromagnetic and acoustic transducers. Option number D is given as laser generated ultrasound transducers. So I am going with option number E, all the above. These four are the types of ultrasonic transducers on the basis of construction principle. Construction principle means the way they are built. Question number 15. The types of ultrasonic transducers or probes on the basis of application are employed are. Basis of application, how it is classified. Option number A is given as contact transducer. Option number B is given as dual element transducer. Option number C is given as angle beam transducer. Option number D is given as delayed line transducer. Option number E is given as protected phase transducer. Option number F is given as immersion transducer. Option number G is given as all the above. We have 6 types of ultrasonic transducers on application, on the way they are applicable. So I am going with option number G, all the above. These 6 are the types of ultrasonic transducers used. Question number 16. The various ultrasonic inspection techniques employed are. Option number A is given as straight beam ultrasonic inspection technique. Option number B is given as angle beam ultrasonic inspection technique. Option number C is given as time of flight diffraction inspection technique. This is also called as TOFD inspection technique. Option number D is given as phased array ultrasonic inspection technique. Option number E is given as immersion ultrasonic inspection technique. Option number F is given as all the above. The various ultrasonic inspection techniques are. We are using inspection for determination of discontinuities and crack in various levels. There are we will be passing straight ultrasonic waves in angle format, forming an angle. We will be passing it, and there are time of flight diffraction inspection, where time is calculated. Their phase array means any change in phase. Immersion ultrasonic inspection technique. So these 5 are the various ultrasonic inspection techniques employed. So I am going with option number F, all the above. Question number 17. The most common modes of data presentation in ultrasonic testing are. The common modes of data presentation are only just 3. A scan presentation, B scan presentation and C scan presentation. How you will present this data in ultrasonic testing? Means you are getting some results. That results are presented in 3 formats. One is A scan presentation, other one is B scan presentation, other one is C scan presentation. So I am going with option number D, all the above. Question number 18. The variables that are influencing the results of ultrasonic testing include. The variables that changes the results of ultrasonic testing are, that has an impact on the results of ultrasonic testing are. Option number A is given as temperature. Option number B is given as alteration. Option number C is given as frequency. Option number D is given as grain size. Option number E is given as surface condition. Option number F is given as all the above. There are more variables, but these are the important variables. Okay. Temperature, if there is a change in temperature, we will have different ultrasonic result. It will temperature has a direct impact on ultrasonic testing results, and alteration also, frequency also, grain size also, surface conditions also. So I'm going with option number F, all the above. Question number 19. The acoustic emission test AET method. Origination and progression in an stressed component can be identified when the component is subjected to repetitive or continuous stress. In acoustic emission test, if you are applying an acoustic emission test for a stressed component, in stressed component we know there will be stress. In that stress we can find orientation. If there is a stress, first strain must come, then stress will be coming in a component. If you're, I told in my video even strength of materials, I told you, if we are applying a force, first the strain comes, then we'll having stress. Just watch that video, you'll get a clear concept on what I'm saying now. If first we will be applying a force, then the strain comes, then we will be having stress. If there is strain, there will be some deformation. That deformation can be tested using acoustic emission test. Okay, acoustic emission test method, flaw orientation. The orientation, the dimension or the shape of the flaw means defect, and progression in a stressed component can be identified when the component is subjected to repetitive or continuous stress. We are applying in a stress component, that is, we are applying a repetitive or continuous stress. In that component also we can find the orientation and flaw or progression of the flaw. Orientation means the shape, and progression means depth. That shape and depth of the flaw can be identified using acoustic emission test. This is a true statement, so I am going with option number A, true. Question number 20. The factors influencing acoustic wave propagation and data acquisition in AET are. What are the factors influencing acoustic wave propagation and data acquisition? The factor how the wave propagate. The factors which influence how the wave propagate means how the wave move, and data acquisition, how data is acquired in AET process are wave propagation, wave velocity, noise, attenuation, pseudo sources. Option F is given as all the above. Wave propagation means how the wave propagate. Then wave velocity, which velocity the wave propagates. Then noise, if there is any noise, then there will be some change in results. Okay. Attenuation means attenuation is a combined effect of scattering and absorption by a material. And pseudo sources means some they'll be looking at sources, but they are not true sources. Okay, so option by F, all the above. I'm going with option number F, all the above. This 5 are the factors that influence acoustic wave propagation and data acquisition in AET. Question number 21. The main components of an acoustic emission testing setup are. In an acoustic emission testing setup means that whole equipment, what are the components there? Option number A is given as sensor, option number B is given as couplants, option number C is given as amplifiers and filters, option number D is given as data storage and data analysis, option number E is given as all the above. We need sensors to detect the motion or to detect ultrasonic sound waves, not ultrasonic, sound waves. Acoustic means sound. Okay. Couplants means to reduce the distance between transducer and the material. Amplifiers increasing, and filters, we need filters to detect the actual sound, and we'll have various sounds in environment. To detect the particular sound we need filters. Data storage and data analysis, we need it, to store the data, and for data analysis we need some component. These 4 are the main components of ultrasonic emission testing setups. With option number E, all the above. Question number 22. The modes of AE signals are acoustic emission signals are, we have three types of not three, we have two types of modes in AE signals. One is transient signals. We have generally two modes of AE signal. We'll see first the options. Option number A is given as transient signals. Option number B is given as burst. Option number C is given as continuous signals. Option number D is given as both A and C, and option number E is given as A, B and C. The modes of AE signals are, generally we have two modes of signals, that is transient signals and continuous signals, but transient signals is also called as burst. So I'm going with option number E, A, B and C. Generally there are two modes of AE signals which just pass in transient type and continuous type. Transient type means sending all one by one, not continuous, all at a time, and continuous means giving continuously. If you are having 100 apples, you are throwing 100 apples at one time and sending 100 apples one time is called transient signals. If you are having 100 apples and you are throwing one apple continuously, one by one continuously, that comes under continuous signals. Just I am saying for memory purpose, for your memory to keep in your mind. Then transient signals are also called as burst. Their transient signals other name is burst. So I am going with option number E, A, B and C. Thank you guys. Thanks for watching. If you hope you like this video, share with your friends so that they can benefit. Thank you guys. Thanks for watching. Bye.